Welcome to our workshop on test gap analysis. I really appreciate that you take the time. Thanks for joining. Successful software grows and grows and gets more functionality. However, at the same time, release cycles are getting shorter. So as testers and test managers, we are faced with the challenge that we must make sure that more and more functionality works, but get less and less time to do so. This increases the risk that bugs slip through testing into production. In this workshop, we want to present test gap analysis as a method that reveals untested changes, because we know both from a gut feelings and from decades of empirical research that those untested changes are especially error prone. The workshop has 4 parts. In the first part, I will outline the general idea and the research foundation of test gap analysis. Then Fabian will talk about practical examples and experiences from customers. And third, Jakob will do a demo of test gap analysis in team scale live in action. And to wrap it up, I will present a case study on the return on investment, how much benefit the introduction of test gap analysis yielded at our customer Munich Re, where we introduced it like 7 years ago. Before we start, one comment on moderation. Whenever you have questions, please interrupt me and ask that question directly, either via chat or directly via microphone or camera if you want to. And my colleague Sven is in the meeting as well. And if I don't see the question in the chat, he will interrupt me and ask the question. And it needs not be a well-articulated question. If it's completely fine if it's skepticism or doubt or your own experiences. The more interactive this workshop gets, the more information you can take out of it. And I think the more useful this will be for you. A short note on myself. My name is Elmar. I'm one of the founders of CQSE. And I've spent the last 15 years working on and with test gap analysis. At first in the research group at the University in Munich, when it was still a research idea, then a research prototype, until 10 years ago when we first implemented in a tool in our company, and in the last years with a lot of customers that employed in production. And I still find test gap analysis very fascinating, because while other software quality analysis ideas are often very specific to a certain programming language or domain, test gap analysis tackles a challenge that is very ubiquitous. I don't see that it's limited to a certain programming language or domain. Who are we as a company? CQSE is a spin-off from the Technical University in Munich. We founded it 12 years ago and moved into our first offices 10 years ago, and bootstrapped, and are now 50 computer scientists, 20 of which hold a PhD in software engineering and quality analysis. And we have 3 offices in Germany. Our biggest office is in Munich, from where I am sending right now. But we also have colleagues in California and in different home office locations all over Germany. So wherever you are, it's likely that there's a colleague who's in the same time zone as you and can answer questions even after this workshop if you have them. Enough prelude. How can we get the most benefit out of our limited testing resources? Most teams we work with use 2 different approaches to testing. Whenever they test a new release, they first make sure that the most critical functionality works. So they typically have one suite of regression tests that always runs independent of what was changed. For example, one of our oldest customers does telemachines, where you can withdraw cash with a credit card, and they make sure, independent of what was changed, that it's never ever possible to withdraw cash with the wrong personal identification number. But the rest of the testing effort is free to test those areas that are most likely to contain new bugs, because it's usually not possible to test everything in every single release. And the very basic idea behind that is to make sure that the changes we made since the last release were tested during testing, either by automated tests or by manual tests. What surprised us is how hard that is to do in practice. because the idea is so simple. Why is it hard, and why do we need dedicated tool support to see where the untested changes are? And to illustrate that, I want to outline some of the reasons, and then a quantitative study we did with Munich Re, why it's hard and what the consequences are. What most teams do when they plan their testing efforts is to look at what changed. So they look into the issue tracker. What did the development team change since the last release? And this slide contains a time travel through our own development effort. On the left, 15 years ago in the research group, we used Bugzilla. This is a screenshot from back then. Then when we moved into our first company office 10 years ago and worked from the same room, we had a whiteboard where we moved cards around. And then a lot of years ago, we moved to Jira and do our issue tracking there. And even if we manage to look at all the tickets during testing that are in there, it's hard to get those changes tested for two reasons. The first one is that depending on what the issue actually describes, it's hard to make sure to execute the code that was touched during the implementation of that issue during testing. And that is because some of the issue types don't describe changes to functionality, but changes to infrastructure or code. And to quantify that on our own issue tracker, we analyzed how many issues we have in which category. And the typical categories in the literature are adaptive, where a third-party component changes and we must adapt our code so that it still compiles. Preventive, where the developers clean up the code, do some refactoring to make future changes easier. Corrective, which are bug fixes, or perfective, which are new functionality. And in our case, 15% of the issues implemented of the 2,000 we looked at are adaptive or preventive. But if I do black box testing and see an adaptive or a preventive change request, it doesn't talk about functionality, but about code that was changed. So it's really hard to know what sequence to click through, or what UI test to automate, or what end-to-end test to program, for example, to cover those tickets. So a lot of these changes can go through testing unexecuted. In these cases, it's unclear what must be tested. But the second and bigger category is that we see a lot of projects where certain changes are not documented at all. One of the projects we worked with had a lot of management attention and pressure, and they had 5 priorities, but everybody knew that only the 2 highest had any chances of being implemented at all in the next year. So whenever anybody needed a lower priority change to be implemented, for example, because they had promised that to their customer, they wouldn't put it into the system because they knew it wouldn't get put into the iteration and implemented anyway. But instead, they went directly to the developer they knew personally and kind of sat on their lap and didn't go away until that was implemented. And obviously, that developer then didn't integrate that or didn't document that in the issue tracker either. And this, in that system, like a third of the changes were under the radar. So even if we as testers and test managers look very, very thoroughly at the information that's contained in the issue tracker, it's hard to make sure that we really hit those changes during testing. So what are the consequences in practice? We did a research study together with Munich Re on one of the business information systems to quantify how many changes slipped through testing untested, and then what the consequences are. And for that, we categorized all the code into what changed, what was tested, to have the untested changes we could focus at. We did that study retrospectively for 1 entire year and looked at 2 separate releases. In the first release, 15% of the code was modified, either because it was new code or because it was changed code. In the second release, again, 15% of the code was modified. And for that study, we tracked fully automatically the entire testing effort, both automated tests and manual tests. And we saw that in the first release, 50% of the changes slip-through testing entirely unexecuted. And in the second release, 60% of the testing of the changes slipped through untested. And what we then did was, for the next half year after each release, we analyzed every single bug that was reported by the users in production. And together with the developers, we pinpointed it in which of the areas it was. And what we found out was that the probability of production bugs was 5 times higher for the untested changes. And this was kind of what we expected. What we were really surprised about was that in both releases, half or more of the changes slipped through testing entirely untested. And that was surprising to us because Munich Re had back then already a very structured test process, and everybody expected that number to be much lower. So the basic idea of test gap analysis is to provide that information before release. The research study was retrospectively, but the goal of test gap analysis is to give you this information before you release, so that you can make a conscious choice whether you want to fix those test gaps or whether you want to ship this way into production. And the analysis idea is very simple. We combine a static and a dynamic analysis. With a static analysis, with a dynamic analysis, we capture the test coverage during automated and manual tests, and then we can put that together to see where are the untested changes. And to show how that analysis works, I want to introduce a visualization called Treemaps, which we would like to use to talk about test gap analysis results. And the basic idea of a Treemap is simple. We use rectangles to visualize components in the software. And the size of the rectangle corresponds to the size of the component in lines of code. This is a business information system with 1.5 million lines of C# code, and the components have very different sizes. And now if I drill down, every small rectangle is a file. And if I drill down even further, every tiny rectangle now, every tiny black rectangle is a method or function in that C# code. And here's roughly 20,000 functions in this 1.5 million lines of C# code. And it still holds, the bigger the rectangle, the bigger the corresponding method in lines of code. And now I want to use that visualization to depict changes, execution information, and then test gaps. This is the change information after 6 months of development of a 30-person developer team. Back then, this team now releases much more frequently, but back then they released 2 times a year, so they had 6 months between releases. And we see here that gray is unchanged functionality. So these methods run in exactly that same version in production right now. And orange and red rectangles are modified in new code. So we see in this part of the system, the team changed a lot. In this part of the system, not much changed. I use the same visualization for test coverage information. And here we get this picture. Gray means not executed during testing. Green means executed during testing. And this map includes both manual and automated tests, and also aggregates across different test stages or test environments. What we often see is that there's a certain amount of unit tests that runs every single build, so maybe every hour or at least every night. Then there's often a certain set of end-to-end automated tests that are executed less frequently. And then there's often stages for manual testing, where there can be exploratory tests or manual click-through end-to-end tests. And in this map, we have from several weeks of testing from a test factory and from automated tests, all the coverage combined and aggregated into this picture. So how does that look like if we put that information together? On this map, we see the test gaps. Now, gray means not changed since the last release. And empirically, we know that the defect density in those areas is lower than in the rest, because we've tested them in previous releases and users have already reported bugs for them. The colored parts are the new code. And only if it's green was it executed during testing, either by manual or by automated tests. Now, what does that mean? How can we interpret the color? I just see the one question, which tool made this representation? Our own tool is called Team Scale. We have it later on in the demo, and those tree maps are also made with Team Scale.
Maybe since you already interrupted, there was a question how we record the test coverage for manual tests, if that's possible to be automated as well, or if that's done manually.
Yes, thanks for the question. Very good question. And the simple answer is, with the same tools that we also use to record automated test coverage, because the coverage profiler doesn't care about whether it observes an automated test or a manual test. And the key for that is to make sure that the coverage profiler is present on all the environments in which manual tests are executed, and to set up a monitoring so that you make sure that we really get all the manual test coverage. Which tool that is depends a lot both on the programming language and the execution environment. Maybe we can talk a bit more about that later on when we speak about the practical examples, Fabi, or later during Q&A. Sven, are there further questions regarding how we collect that information?
There's a question whether we can get separate reports for different test stages.
Yes, Matthias, thanks for the question. We can. What we try to do is to capture all information and to tag it with both from when it was and where it was, so that you can look at different stages individually or merge them on any level you like to see them merged. Fabi has a slide on that later on. So how can we interpret that information? In the green areas, we don't know how many bugs are left, because while we know it was tested, we don't know how thoroughly it was tested. Even if every single line was executed during a test, we don't know if we have found all the bugs. This is one of the fundamental limitations of testing. We can never prove the absence of bugs. We can only show the presence of bugs. And obviously, test gap analysis can't change this fundamental limitation. However, for the orange and red areas, the conclusion is as trivial as true. We can't have found a single bug in there because we never executed that during testing. And we know that the likelihood of bugs is much higher than in the other areas. So our basic goal of test gap analysis is to allow for a conscious decision about whether you want to ship that into production or if you still want to make further changes. And this tree map here was the day before the planned release. And for this system, the decision was made to postpone the release and to do further testing before it was then released, and Fabi will go into more details about why that is. I want to spend some words on how we integrate that into the test process so that you have a better feeling of how our customers use that on a high level before we dive into individual examples. And the basic idea is that we automate the entire analysis process. We connect to the version control system to fully automatically get the changes that happen on all the branches and compute the delta to the last release or any baseline you want to compare against. And we use coverage profilers for all the languages that are used for the implementation of a system, both for the automated and the manual tests, and compute those untested changes on a regular basis, hourly or nightly. It depends a bit on how the test setup looks. And then developers, testers, and test managers can look at those dashboards on different levels of granularity to make a conscious decision whether this fits their expectation or if there's any big gaps they need to react to. And on my last slide about the general idea, I want to stress 2 points. The first one is the bottom one here, which I mentioned before. Even if everything is green on these change tree maps, we can't guarantee that there's no bugs left. There might be bugs in code that was executed, but not in the right way to review that bug. And the second one is we don't aim for 100% change coverage as a goal in itself, because there might be areas in the code where the cost of testing is higher than the cost of bugs that remain in there. For example, if it's functionality that is only used internally, maybe bugs there are not so expensive there, and maybe it's cheaper to live with that. But our goal is to allow for a conscious decision about whether you still want to test that. This wraps up the first part about the general idea behind test gap analysis.
There's more questions in the chat now. So can we merge coverage reports from different technologies?
Thanks for the question. Yes. What we often see is that in large systems, there's different programming languages being used. And we can create tree maps that merge, that include different programming languages and also include coverage for these different programming languages. Or should you, for some reason, use different coverage profilers for different parts of the system written in the same programming language, we can also merge that here. Thanks for the question. Is the test gap analysis a concept or a tool created? We call the concept of the analysis test gap analysis, and the tool in which we implemented this is called TeamScale. Sven, maybe you can type that in the chat.
Sure.
We have different analyses, but we have implemented them all in the tool scale because we thought it was easier to remember one tool name.
Then there's the next question. Do manual testers have to use a special debug build of the system under test, or can you track the test coverage also on the release build?
Also a very good question. And I think the answer depends on the programming language involved. For Java, for example, the profilers we typically use attached to the virtual machine and do this instrumentation on the class level during load time. So we don't need a special build. For other languages like C++, the profiler must instrument either the bytecode or the source code. So that depends a bit on the language you use. I see no further questions. If you think of any questions during the rest of the talk, even if they are about the first part, please feel free to ask them in the chat. Fabi, I think now is a good time to grab the screen.
Already did.
Okay, perfect.
All right, then I'll continue with the second part. I have two slides about the technical details, although Elmar has already covered most of that. So I'll go quickly over those. And then afterwards, I have three practical examples from how our customers are using the analyses. I hope those help you relate it a bit to your own development processes. So in terms of how does it actually work, we saw before from Elmar's slides that we need two components to make the test gap analysis work. One is code changes and the other is test coverage. And code changes is the easy part. We simply get that directly from your version control system. This is a bit different than other static and dynamic analysis tools that you might know, because they usually integrate in the build. We integrate with the version control system. So your Git repository, your SVN repository, your TFS repository, what have you. This has a few advantages. One is that when you check something in, we don't need to wait for a build to run. We can already analyze the changes that you've checked in and can immediately tell you that there are new test gaps. On the other side, Elmar already mentioned that we need test coverage, and we get that with specialized profiler tools. And as also mentioned, which tool we apply here depends a lot on what kind of programming language you're using and what environment you're running it in. We have a few tools for certain languages that we make ourselves. For a lot of languages, we rely on tools that are already out there because usually there are some good open source projects that allow you to instrument your code. And then it doesn't make sense for us to write another one when there's already something good out there. But basically all of these tools, they record while your program is running, which lines of codes are getting executed, independent of whether that is the program is being driven by a human clicking on some buttons or some automated API test that fires off API calls, or maybe a unit test that runs the code directly. Those profilers usually don't care which of these scenarios it is. They will always just give us a report that tells us line 5 was covered, line 10 was not covered. And that we can upload to TeamScale, and TeamScale does the rest, which is combining these two pieces of information and telling us exactly where our untested code changes. We already also saw that we can tag different types of coverage with different names. For example, we could say this coverage that is coming from this system is our component test, and when it's coming from the other system, it's our integration test. And then TeamScale lets us select at runtime which coverage information do we want to look at to calculate the test gaps. And we can either select one of those, or we can also combine them in any fashion we like. Because usually one important question is which code was not executed in any of our test stages, because this is obviously the most high-risk code that we still have before release. Now for the examples. The first one that I have is a so-called hotfix test. I think this is something that everybody knows. You have something running in production, a customer notices a bug that is high impact, so you want to fix that in a short amount of time to make the customer happy again. It's usually not a big change in the code that is happening here. Usually these are rather localized in the code base. And also, since the customer already noticed something that is wrong, we usually don't want to ship a new version that has other bugs. So we want to be extra careful that what we're shipping is rock solid and there's no extra bugs in there. And the case that I have here is from one of our customers, and this is an SAP system, so a business information system, but that doesn't really matter. What we can see here is the code changes that the developer did for this hotfix. So in this case, they touched 8 different methods to make the hotfix. And as a tester, when I'm now trying to test the hotfix changes, the first thing I do is I completely ignore everything that TeamScale is telling me and do what I always do, which is to just do a retest of the bug. So I do the same steps that we did to reproduce the bug and look if it's still there. And afterwards, my expectation would be that with this, I already have pretty good coverage and hopefully even covered everything of the code changes that the developer did. For this specific case, the picture that we got afterwards, after the retest, was this. And as you can see, it was unfortunately not the case that the retest already covered all code changes, but rather it only covered half of them. So the other half was still completely untested. And the tester talked to the developer in this case. And what happened here is something that we also see very often in software engineering, which is in order to implement the bug fix, the framework that is used here for this business information system forced the developer to also implement certain other edge cases that were not part of the actual reproduction of the bug. So in this case, the specification, so to speak, was a bit incomplete. And the developer, while they were implementing, realized this and had to also implement the edge cases. And then the interesting question at that point was, do we rather want to ship the hotfix right now, or do we think these edge cases are important enough that we want to do a test of those as well? And as you can see, this is where the tool really helps you bring out areas where there might be possible risk. But in the end, the decision whether another test is needed or not, that is up to you as experts for your system. And in this case, they actually said, yes, these edge cases can actually happen in production. We should make sure that these also work. So they did another test, and afterwards, they actually achieved 100% change coverage for the hotfix. The second scenario that I have with me is a so-called release test. This is something that I'd say a few years ago was pretty standard with all of our customers. They had a development phase, and during that phase, there was mostly development activity. And then they had a dedicated testing phase right before their release, where they try to make sure that what they're releasing is bug-free as much as possible. And then after the testing phase, there's the release happening. And what I have here is actually the example that Elmar showed before, which was a dedicated release test where the tests were mostly manual. So for over 2 weeks, a test factory in India with 5 testers was executing manual test cases. So that somebody had written down, okay, click this, and then check if the value here is 75, for example. And they did this and then reported back any bugs that they found. And they did this on 6 versions of the system, because obviously when you're doing a lot of manual testing, you're not gonna start your testing and then the first bug fix version comes in and then you go back to 0 and start with the first manual test again. That is too expensive. But rather, when a new version was released by the developers with some bug fixes, they just continued with the next test case on the new version. And so the changes you've already seen for that release before. Same with the test coverage. And when we overlay that, you get the same picture as before. And as Elmar already said, this was the day before the release where we showed this to the testers and the developers. And obviously, it's quite obvious that there are large amounts of new code that is not being tested. For example, in the lower left here, there's a whole component where no test activity at all was happening. And up here, we also have a lot of red areas. This was very concerning to the team. And in this state, the big question was, do we want to release at all, or do we rather postpone the release and do this later? And actually, afterwards, we were pretty sure that some people in that team were expecting a picture like that, because what was happening here, the idea here was to actually start with automating a lot of test cases and running automated UI tests. And for that purpose, they tried to do all the tests for the new functionality in automated tests. Unfortunately, this automation project failed completely. Not a single test case was finished in time to run them for the release. And the test factory in India only got the regression tests. So they did what they were told and they did it well, but unfortunately they had no chance of actually covering the new functionality with the old regression tests. And so at that point, the team here decided that they can't release it like this. They have to do something to also cover the areas there. And unfortunately, trying to get that covered with automated tests was unrealistic, since they weren't finished there yet with actually running any tests at all. And also writing a lot of additional manual tests for the testers in India would also have been too time consuming. So what they decided to do was to run a so-called explorative test, or some people also call it the monkey test, where they asked the people who actually ordered the new features, the requirements engineers, the end users, and so on, to just go in the system, and you know what you ordered for this release, just try to get as much coverage as possible and make sure that what you ordered works as you expected. And so people were doing that over 2 weeks again, on 8 different versions of the system in 307 test sessions. And as you probably expected, code changes are roughly the same, modulo some additional bug fixes. The code coverage is quite different this time because they did different things. And then this was the final picture that we got. And as you can see, there's no longer these gigantic red areas. So pretty much everywhere there were code changes, there was at least some coverage. So that was a big sigh of relief from the team when they saw this. There are still some larger areas where there were untested code changes. And I've highlighted 3 here. I'd like to tell you about those. The one at the top was an interesting effect that we had here, because the release cycles were so long. Some of the developers were already out of work before the release was finished. So they were already working on some stuff for the next release, some tickets for the next release. And of course, this was not yet accessible, this code via the UI. So this was basically still dead code, but to be used in the next release. So here there was no test necessary at the moment. So they put a check mark next to that. On the other hand, the second item we have here, this was code that was actually supposed to be removed during this release. So it's a feature that they deprecated and removed from the tool. But unfortunately, this code was not deleted. So in this case, also no test was necessary, but it was a good input for the team to still delete these classes here and get rid of the code that they don't need to maintain anymore. And then finally, this item here, this was functionality that they classified as actually very important for them, which was an export of some risk data into an Excel file. But the export was hidden behind a dropdown. So during the monkey test, nobody actually saw this and tried to click on it and tried it out. So this remained untested. And for this, they still scheduled another small test to make sure that this actually works as expected. So I hope you can see how, even if there's a lot of code changes and it's a large code base, this kind of picture can still help you get a good feeling about how risky is a release right now, and do we still have untested functionality that we want to retest before we do a release.
Maybe Fabi, at this point, there's a question about how we get information about what's not tested in more detail, because the picture, the Treemap is of course only showing that on a very high level.
Exactly, excellent question. What you see here is of course very static. This is only an image that we have in the slides, and later on in the tool demo, you'll also see what it actually looks like in the tool. And in the tool, this is all interactive. When you hover over one of those rectangles, TeamScale will tell you exactly what method is this, in which class is it, and so on. You can also click on it and see the actual code changes and the commits in the version control system that affected this method and so on. So you have a lot of interactivity and a lot of ways to drill down and find out what is this. I'll also in a minute show you a different kind of view that might be even more helpful, where we are also relating the code changes to the data that you have in your issue tracker. So you can also see the test gaps more on a level that talks about functionality rather than lines of code, if you want. More questions? All right, then let's move to the third example. Because this sort of big release test before we do a release, we see this less and less with our customers, because what is happening, people are working more and more agile, release cycles are getting shorter and shorter, so it's harder to do the whole testing in one big block, but rather what people want to do is they try to have the testing activity interleave with the development activity. As soon as the feature is ready, we try to test it in whatever fashion it is possible. And this means that testing is no longer happening in one big block, and it's also no longer happening on a special dedicated branch with a clear release scope where we know all the code changes that went into the release, but rather it's happening all over the place. Maybe you're doing feature branches and there's tests on every feature branch. And so as a test manager, it's much harder to find out what testing has already happened, where are actually still gaps in the code that we're going to release in like a week, and to get this sort of overview. And we've seen this challenge for a few years now, and we had to find a different type of visualization to make it possible for people to still get this overview. And what we do here is what we call issue test gap. And this means we take not only the data from your version control system and the test coverage, but we also take what is in your issue tracker. And when I say issue here, please mentally insert whatever name you use for the types of tickets that you have in your issue tracker. Some people call it a user story, or they call it a bug and a feature, or they call it a defect and a task, and so on. So just use whatever you're used to here. But basically, these are the unit of work that you have in your issue tracker, where you describe exactly what should be changed in your software system. For example, for the current release or in the current sprint. And TeamScale can correlate that information with the code changes that we make and with the test coverage that we gather to tell you for every ticket in your, for every issue in your issue tracker, what is the test gap? What code was changed? And did we cover that code during any of our testing efforts? And what this looks like, you can see here. And you can use this, you can fire off any kind of query that you want here to get a list of the tickets that interest you. So some people, for example, like to look at all the tickets for the current release, or some like to look at only the high priority tickets. And others like to look only at the tickets that are assigned to themselves, and so on. For every ticket we get in the details, the same thing we get in the big Treemap, meaning all the code that the developer changed to make the ticket, to implement the ticket, to make it happen, is in the Treemap here. So this is no longer the whole big system, but rather a very small and manageable scope. And we see for every method if it was tested in any of our test stages or not. And the nice thing is, this is now on the one hand very manageable. So this is also great for me as a single tester when I'm trying to figure out what do I still have to do to cover this ticket properly and make sure this is tested well before, for example, before we merge it to master if we're doing feature branches. And it's also great for me as a tester because I know exactly who to talk to if there are test gaps that I can't explain why my testing hasn't caught them, because I mean the developer is right here as an assignee or as a ticket creator and so on. And I have all the data here that we also have in the issue tracker. So this makes it very easy to do a quick back and forth between testing and development and align the two and make sure there are no critical test gaps for a feature before I declare the feature done. And actually a lot of our customers put looking on the test gap Treemap in their definition of done. You can't say the ticket is done unless somebody has actually declared all the test gaps as okay in some way. How does that work technically? How do we get the connection from code change to issue in the issue tracker? Very simple. We first import the relevant issue from the issue tracker. So that works for a variety of different tools here. And then we look into the commit messages of the commits. And there you can see if you reference the ticket from your issue tracker in the commit message, if you say my ticket has number 1, 2, 3, 4, 5, and you enter 1, 2, 3, 4, 5 in your commit message, and Teamscale knows all the methods changed in that commit belong to that issue and can correlate those. The same also works if you put the issue number in your branch names, which also some people like to do. Then Teamscale knows everything that's happening on this branch is related to this issue and can correlate that. And then it can also take the test coverage of those methods and also correlate it with the issue and give you the issue test gap. At this point in time, any questions about this issue test gap view?
Not specifically, but there's a question regarding how we record coverage for exploratory tests specifically, because we don't have test cases there, right?
Yeah, that's true, but the recording still works the same as for all the other types of tests. So the coverage is recorded by a coverage profiler that's installed on the system where your application is running. And it doesn't matter to the profiler if you have a specific test case in some other tool, or if you're just clicking around however you like, it doesn't matter. In the end, it just generates a report what was executed and what wasn't executed. So it doesn't even have to know that there are test cases in some other tool. More questions or follow up to that question?
Yes, there's another question. Is it possible to automatically detect all blocks of code that will never get executed?
You mean to find like that code? Is that the question?
I think so.
There are some approaches to find that code. Some of them we can also do with Teamscale, but that's really quite a different type of analysis. So this is not something that comes with test gap analysis, but it's one of the other analyses that Teamscale can do.
And the last question, how does business analysts and testers know based on the red areas what has to be done, because only developers know what the actual code is, right?
Yes, very good question. I'll quickly jump back to that slide here. That's a very good observation. So as if you're in a pure tester and don't really know much about the source code, then of course the method names and so on will usually not tell you that much. So really what is needed here is interaction between development and testing. And I think this is also one of the strengths of the tool. What we've seen a lot of times is that once the test gap analysis is in place, testers and developers talk a lot more with each other than they did before. And this is a good thing, because what has to happen is you as a tester did everything you could to make everything green, but it didn't happen, for example, for this ticket here. So you go to the developer and ask them, hey, look, I did this and this and this. Why is there still red stuff? And then the developer can look at the methods and can say, yes, okay, there was this edge case, or this class is actually for another feature and I did some refactoring there. And then together you can usually decide quite quickly and quite easily, is there still another test needed? And if so, what kind of test would I have to do? And so this really helps you also to speed up testing a bit, because you have something very concrete to talk about, and these are these test gaps that you want to close. More questions? Did that make the question? Did I answer the question? I guess so. All right, and that concludes my part then. I would hand over to Jakob for the demo.
Welcome also from my side. My name is Jacob, and I use Teamscale every day together with customers, and those customers use Teamscale often to perform the test gap analysis. And I have the pleasure today to demonstrate the things my colleagues presented on the slides in a live demonstration. And since I want to present test gap analysis, I need some system under test, and I brought Pixelitor today. Pixelitor is an open source drawing application implemented in Java. And the story behind it is that Elmar from the development team implemented a ticket recently, an issue, and I have now the responsibility to check whether this ticket is thoroughly tested. Since we will perform the analysis in Teamscale, I will now close the PowerPoint presentation and jump in my browser. And I have already opened the Teamscale website. I have to move the Zoom controls. Teamscale is a application implemented in Java, and it normally runs on a server. Today, it runs on my local machine. That is also why it states localhost right here in the URL. If I log in, I'm navigated directly to the dashboards perspective. You have several dashboards in Teamscale that all allow a different perspective or viewing angle on quality metrics that are calculated by the tool. Today, we will stick to the dashboards perspective, and later on, we will navigate to the issue test gaps. I prepared 3 dashboards today. Each of them are only showing one single tree map, namely changes, execution, and test gap. Let's start with the changes. And now you see the test gap tree map in an interactive version. So if I hover over one method, actually I get shown which method it is. As a repetition, all the green rectangles represent methods that are not changed since some baseline, since some start date of the analysis. We have the date right here. It is the 1st of January 2016. That is our baseline for today. And the analysis respects changes until today. So the visualization is called Treemap, and it also represents or visualizes the tree structure of the folders and the files. So each method that is in the same file is located next to each other, and also files that are located in the same folder are next to each other, represented in the Treemap. As already said, all the orange rectangles are methods that existed at the baseline and were changed afterwards, and all the rectangles, we have a big block here that are colored in red, are added since the baseline. If I now change to the execution Treemap, we do not respect changes anymore, but show the test coverage. And all methods that are colored in green right now are the methods that were executed in the test, and all methods in gray are not executed yet. So for normal circumstances, that would be catastrophic because only 3 methods were executed in the test. But we did this on purpose for the demonstration, because on the one hand side, you can count the methods on one hand, and we can roughly remember the location of the covered methods. We have 2 methods covered on the lower left-hand side and 1 big method covered on the right side. So let's switch to the last dashboard. It is called test gaps, and it shows now the results of the test gap analysis. That is, we stack the execution Treemap on top of the changes Treemap. And that is why I quickly jump back to the changes Treemap. We have, again, a lot of orange and red rectangles. And now we change to the test gaps perspective, where we lay the execution and the coverage now over the changes Treemap. And we remember we have 2 methods covered on the lower left-hand side. They are now that were methods that were orange or red, and they are now green because they were executed in some test. We also remember that there was a big green rectangle in the execution Treemap that is now gray. That is the case because this method was not changed since the baseline. It is running since before the baseline in this implementation as it was before. A lot of new users of Teamscale ask, how do we come to the source code then? Or is there any possibility to dig deeper? And there is. We see already where the method is located. The method is called filter, and it's in the motion blur op class. And I can click on that method. I can again click on open method, and then we get the so-called method history. The method history shows how the method evolved over the time in the software system. And of course, it was added sometime. Then we have the current baseline, which is January the 1st, 2016. And then it was modified a lot of times. And the last time was done by Elmar. And we also see that this method was covered afterwards. back to the dashboard and the test caps perspective, test cap Treemap. So this Treemap shows me a lot of information, and this is great for the dedicated release test as Fabian talked about it. So if I want to know between the release A and B, what changes were performed and were they executed in some test. But you know my story for the demonstration, I'm only responsible to test a single ticket. So this shows me a lot of information that I don't need. As promised, we will now switch to the issue test cap perspective or view. And as Fabian also already said, TeamScale is not only connected to the version control system, but also to the issue tracker, and we can list the issues here. Now all the open issues are listed, but we could also define queries that list the issue that are assigned to me or that belong to the current iteration. For us today, the issue with the ID number 1 is important to us, and it is called Improve Gaussian Blur Filter. If I click on that, I get the issue detail view, and it shows me several information that is retrieved from the issue tracker. For example, the title, the issue ID again, the status is open, the ticket was created by Dennis, assigned to be implemented is it to Elmar, and it also says what should be done in this ticket. The Gaussian blur filter could be improved. It is not really Gaussian enough. So there are several sections that shows us information about that issue. And let's open at first the commit section. There are 2 commits associated to that issue. And that is possible because Elmar, whenever he commits a change that is associated or should be that is done in course of one ticket, he mentions the ticket number in the commit message. In this case, you can see it here. He mentions ticket number 1 prefixed by a number sign. So 2 commits. With the commits, we can calculate which files were affected. They were changed to files. We also see some findings from the static code analysis here. But for us, center of attention is the test caps, or are the test caps. We see this Treemap is much more smaller than the first one that went over the overall system, and it only counts 4 methods, 4 changed methods, 1, 2, 3, and 4. And what I like to see is that 2 of them are green by now. What I don't like to see is 2 of them are still orange. That means they were not tested after their latest modification. What I want to do now is to go into a manual test, meaning I will open the program now and perform a manual test based on the ticket description here. And it reads, I should somehow test the Gaussian blur filter. Therefore, I need a running instance of Pixelator, and I will start the program with run on my command line. So it's loading. I know that I need some picture that I can apply the filter to. I will try to paint the TeamScale logo, which is not that easy, I think. And then I want to apply the Gaussian blur filter. It is hidden here. I tested that filter a lot of times, and now I know how it should look like. That seems to be working. I test the extreme values. So that seems to be good. What TeamScale does not do in this case is to track whether a test is failing or passing. So in this time, I just write down that this manual test passes. I click OK, and since my test is concluded, I will quit the program. What you have not seen is that together with the start of the application, we also attached a profiler to that program running. So all the covered methods were recorded during my manual test right now. And what you also have not seen is that this report or this results are automatically transferred to Teamscale, uploaded to Teamscale. And we can also see that in the activity perspective here. I just open it up in the background, and you see it reads manual test coverage upload just 1 minute ago. This also has an effect on the TestGap Treemap. So this is the status quo. And if I reload the page, I see that the big left method that was earlier orange is now green. That is because of my manual test. There was also the question earlier whether we can make a difference between different test stages. And yes, we can. We can, for example, activate or deactivate manual test coverage or unit test coverage, depending on what I want to see. So 3 or 4 methods are covered. That is good, but I'm a bit confused because there's 1 method left that is untested. And I have tested the Gaussian blur filter. There's nothing more in the ticket description what I should test. So I could ask Elmar, but I will just have a look and try whether I can find it out using the TestGap Treemap. I see this method, the orange method, is located in the motion blur operator class. And if I want, I could also shortly inspect the method history. It says some other refactoring. So I'm guessing Elmar did not only change the Gaussian blur filter, but also did apply some changes to the motion filter. I now can decide as a person responsible for the test whether this is a test gap that is okay with me, and I will release or merge this feature as is. But I know how important the motion filter is to the users of Pixelator, and I want to go into a test of this filter. So I start the program again, create an image, this time not the logo because it's too difficult for me. We this time test the motion blur filter, and I have also tested that a lot of times, and that does not look good because some in-motion unsharpness should appear here and does not work. So I write down for this case, test case, the result of the test case is it is failed. I found a bug right now and it has to be fixed. So I can close the program again, Pixelator, and again, the coverage is transferred to Teamscale. Again, we most certainly have some implications on the TestGap Treemap here. And we see now the TestGap Treemap is completely green. And now an important fact that Elmar explained earlier comes to the table, because a completely green TestGap Treemap does not mean that the system is free of bugs, but only that all of the changed methods have been executed. But we know that if we would not have tested that method on the down right side, we would not have detected that bug. That is not, that change is not described in the ticket description here. So I asked Elmar to fix that bug immediately, and I wished it would always be so easy. I just have to apply the fix here. And we go 1 git commit further and have the motion blur operator fixed by now. Also, this code change has an effect on this issue view. So if I reload the page, I see now on the commit section, in the commit section, that there are not 2, but now 3 commits associated with that issue. And it says fixed motion blur filter, and the method on the down right side now is appearing in orange again because it was changed after the last test, or in other words, it was not tested after the latest modification. So that concludes my demonstration of issue test gap analysis. We can also have a short or quick look again on the overall system test gap Treemap. As you might not wonder that now much more changed methods or added methods appear in green right now because our manual test has influence on all the methods in the software system, not only on the changed methods of ticket 1 or issue 1. And you also see that the execution tree map is much more greener now. So this concludes my demonstration, and I would now be open for practical questions, because in half a minute or in a minute, I would change back to the PowerPoint slides. So I cannot see the chat anymore. Please, one of my colleagues will moderate, hopefully. Are there any questions regarding the tool?
So there is a technical question, which is not so much specific to the demo, but maybe we can answer it at that point anyways. It's about how can we deal with configuration changes? How can they be considered in the analysis?
I think that the fundamental problem is that configuration is not executable code, so we can't get coverage for it. At least mostly, it's not executable code. So in the end, we can of course show you where configuration changed, but we can't tell you whether this was executed in some way, because it's simply not possible to tell.
Thanks. So what I did not tell you, that I should retest this feature, the motion blur filter, but I promise you it works right now. Any further questions, Sven?
Yes, there's one more question, also a technical one. So the tree maps show coverage on method level, and the question was at which level we're actually recording coverage. So which level of coverage do we actually have as a basis for test gap analysis?
Mm-hmm. That strongly depends on the programming language your system is written in. So for Java, we often use Jacoco, and this traces coverage on a line-based level. And for C# we often use a coverage profiler that only profiles on the method level. So it depends, the answer.
Maybe a suggestion, since there's also a question about can we do decision branch coverage and so on in the chat. Can you click on one of the methods and just show what it looks like, so people can see that you can actually see the line coverage?
Of course. So in fact, for example, here we would have a method where not all lines are covered. I don't see the chat, so please speak up if I should do any further things here.
I think that was the perfect answer to that question. And there is also a thanks already in the chat. So I guess that answered the question. There's one more question that came up because everything happened so smoothly and quickly during the demo. So the question was whether updating the test gap analysis is actually real time.
Now in the demonstration, yeah, it's real time. So the analysis takes some time for TeamScale, but since the example is pretty small, it's more or less real time here. Yes. If there are no further questions, I would switch back to the slides.
Go ahead.
So what we have seen right now is issue test gap analysis for a system implemented in Java. But don't worry if your system is written in another language. For all these programming languages highlighted in orange here, we have test gap analysis implemented and running somewhere. But also if you're on the more exotic side of programming languages, don't hesitate to ask us whether we can also make test gap analysis running for your system. With these words, the demonstration part is over, and I would hand back to Elmar.
Thanks a lot. Just as a quick check, can you see my slides, Jakob?
Yes.
So for the last 10 minutes, I want to raise the level of abstraction and talk about how we can quantify the benefits of test gap analysis. Because if you introduce test gap analysis in a system, you typically get answered the question, what's it really good for? What is the return on investment? And at the very beginning of this workshop, I mentioned the study we did with Munich Re, where we analyzed how many changes slipped through production untested and how many bugs they caused prior to the introduction of test gap analysis. So with Munich Re, we were in the lucky situation that we had the before and after data, because after the study, they introduced test gap analysis into a lot of their systems. And together with Munich Re, we analyzed 2 years ago what the situation is now and published that the results together with them. And so I am allowed to share them here. And the question we asked is, how much less bugs ship into production because of test gap analysis? And we use this simple mental model to quantify the impact of test gap analysis. And in this mental model, we look at the changed parts of a software system, push them through testing, and look at how many of the bugs we spot and fix during testing. The changed parts of code are displayed as this red rectangle. And since we don't know where the bugs are, we assume an equal distribution across that. And we're interested in the percentage of remaining bugs. And our mental model is simple. In our study, we saw half of the changes slipped through testing unexecuted. So we can't have found 50% of the bugs. For the rest, we did test them, but we probably didn't find all the bugs. But from the study, we know that for every single bug in the for every 5 bugs in the untested changes, there was only 1 bug in the tested changes. So we know we found 4 out of 5 bugs. So 10% slipped through here. So prior to test gap analysis in that scientific study together with Munich Re, we saw that 40% of the bugs are discovered during testing, 60% of the bugs slip through. How does the situation look like now? In most of the systems, we have a test gap of 5% or less, but we made a conservative choice of putting 10% test gap here. So those slip through unnoticed. And for the remainder, we assume the same percentage of remaining bugs in the tests, the same thoroughness of the tests. So again, we find 4 out of 5 bugs here, or more specifically, 18% of the bugs slip through. So altogether, 28% of the bugs in the modified code slip through testing. What was 60% before is 28% now. For the systems we analyzed in Munich Re. So in a nutshell, that analysis, if you're interested, I have much more detailed information on that, but in a nutshell, that analysis showed us that at Munich Re, we managed to reduce the production defect rate by a factor of 2. So only 50% of the bugs that slipped through before still slip through now. And we're happy that we have that quantitative view over a span of 7 years that they back then used test gap analysis. That concludes the high-level view on how much return on investment we saw at that customer. And we've made similar experiences with other customers, but we couldn't include them in the quantitative analysis because we didn't do the research study with them before. Before I want to open the stage for further questions, I used the time where Fabian and Jakob spoke to sneak in one further slide, because earlier on asked if we can use those same techniques in production to find code that is not useful anymore. And this Treemap shows an SAP system, a custom module of an SAP system at one of our customers, several million lines of ABAP code. And there we did exactly what Alfred asked before. We ran the profiler in production for 3.5 years. And everything that's gray here is not executed at all. And then there's a log scale in green, how often something was executed. And you see that in 3.5 years, 80% roughly of the system were never executed at all. And from our experience, this is very useful information if you want to save effort in the future maintenance of the system. You can't always delete everything that's unused. Sometimes, for example, there's disaster recovery functionality, and only because you didn't have to recover from a disaster in those 3.5 years, you probably don't want to delete that. But for the majority of that code, further inspection found that it's just not useful anymore. And parts of that were deleted later on. But our experience is that most customers first use these analyses as test gap analysis and testing. And when they've seen that it works well and doesn't negatively impact their system, then some of them move that into production to collect usage data of their user base. Thanks again for that question. This concludes the slides we brought. And before we move into the breakout rooms, which further questions do you have? Sven, are there further questions in chat?
Not at this point. So for everybody, thanks again for the many questions and attending in the first place. I think this was a really enjoyable and interactive workshop. So I would say that this concludes the official part. And everybody who still has questions, I just opened up the breakout rooms and the speakers will move there now. So you can join them and ask any further questions you might have. Thanks everybody for attending, and have a good day or evening, depending on where you are.
Thanks, and maybe see you in the breakout room.